The image came through on a Tuesday morning, and the engineer who saw it first did not call it a farewell. He called it a complication. Hubble had just finished one of its scheduled looks at Pluto, and the data was doing something it was not supposed to do. The atmospheric pressure, modeled out years in advance, was off the predicted slope. The brightness curve was wrong. Not catastrophically, by enough. By the kind of margin that makes a careful researcher stop, lean back, and quietly ask the room whether anyone else is seeing this. Pluto, 4 billion miles away, drifting deeper into the cold, was refusing to behave. That is the version of the story you were not supposed to hear. Hold 3 facts in your head. Pluto's atmosphere is collapsing on the wrong timeline. Something is holding it up longer than the math allows. The 2006 vote that demoted Pluto is being quietly relitigated by working planetary scientists, with formal proposals on the table right now. This was not a goodbye to Pluto. Pluto is not going anywhere. This was a goodbye to our ability to watch it. The generation that grew up being told 9 planets, then corrected to 8, is about to be corrected a 3rd time. And the correction is not the comforting one. The official story of why Pluto was demoted is cleaner than the actual vote. Start there. The official story is that in August of 2006, the International Astronomical Union met in Prague and corrected a long-standing mistake. Pluto, the official story says, was misclassified for 76 years. Too small, too icy, too different. A careful, evidence-based reclassification took place, and humanity moved on with 8 planets and a clearer picture of the solar system. Almost every piece of that story falls apart the moment you look at the meeting itself. The vote happened on the last day of a 2-week conference. Most attendees had already gone home. Out of roughly 10,000 professional astronomers in the world, fewer than 500 cast a vote. Less than 5% of the field. And here is the part that should bother you. The people who study planets for a living, planetary scientists, geologists, the people who actually build missions to these worlds, were largely absent from that room. The room was full of astronomers who specialize in galaxies, in stars, in cosmology. The vote that defined what a planet is was taken by people whose careers were not centered on planets. Now think about what triggered it. It was not Pluto. Pluto had been on the list since 1930 without serious objection. What changed was Eris. Discovered in 2005, initial measurements suggested Eris was larger than Pluto, and the surveys coming online were going to find more. Dozens, possibly hundreds. If you let Pluto stay, the textbook was going to have 50 planets in it, then more. So the IAU did not solve the science problem. It solved the memorization problem. It wrote a definition designed to keep the number small. A planet must orbit the Sun, it must be round, and it must, in the official language, clear the neighborhood around its orbit. That 3rd criterion was the trap door. Pluto, sharing its region with the Kuiper Belt, did not clear its neighborhood. Demoted. The problem is that under a strict reading, Earth does not fully clear its orbit either. Neither does Mars. Neither does Jupiter, which shares its region with thousands of Trojan asteroids. The rule, applied honestly, excludes most of the planets it was meant to protect. Within 48 hours of the vote, hundreds of planetary scientists signed an open letter rejecting the new definition, out of professional objection. The IAU did not revisit the question. The textbooks updated, the lunchboxes updated. And the gap between public understanding and professional understanding has been growing, quietly, ever since. If the rule was written to keep the list short, the question is no longer whether Pluto is a planet. The question is, what else is out there that the rule was built to hide? Pluto sits 5.9 billion kilometers from the Sun. At that distance, sunlight is roughly 1/1600th of what reaches Earth. The temperature averages around -229 degrees Celsius, colder than liquid nitrogen. Cold enough that the air itself, the thin nitrogen atmosphere, freezes onto the ground each winter and lifts back into the sky each summer. An atmosphere that breathes in and out on a 248-year cycle. And we have only ever watched one half of one breath. That is the first thing to hold on to. Everything we think we know about Pluto's atmosphere comes from a fraction of a single Plutonian year. Here is what Hubble's recent look actually showed. The brightness changes did not match simple seasonal sublimation models. The atmospheric pressure, which should be dropping fast as Pluto recedes from the Sun, is dropping, but not on the predicted curve. And the haze layers, the suspended particles high in Pluto's thin sky, are persisting in conditions where the models said they should already have collapsed. Pluto is doing thermodynamics it isn't supposed to have the energy for. Something is holding the atmosphere up longer than the math allows. Now connect this to what New Horizons found in 2015. The flyby was supposed to confirm a frozen, geologically dead world. Instead, it showed flowing nitrogen glaciers, mountains of water ice, possible cryovolcanoes. Evidence, still debated, of a subsurface liquid ocean. Every assumption astronomers had about small icy worlds got rewritten in 18 months. This is the part most viewers were never told. Our entire model of what counts as a geologically active world was built on a sample of a handful of inner planets and a few of their moons. Pluto wasn't the exception to that model. Pluto was the first honest data point from a region we had been guessing about. And the moment we looked at it closely, it broke the model. The implication is not that Pluto is unique. The implication is the opposite. If a body this small, this cold, this far from the Sun is still doing this much, then the assumption that the other Kuiper Belt bodies are quiet, dead, simple, that assumption is built on nothing. We have not looked at them, we do not know. And here is where the Hubble data becomes uncomfortable. The atmospheric anomaly is not a one-off measurement. It is a trend across multiple observation windows. Something is sustaining a thin atmosphere on a world that, by every clean model, should be losing it faster than we are seeing. If Pluto is alive, the problem isn't Pluto. The problem is how many more of these we already know about and pretended not to. Start with the names, because the names are not in your textbook, and they should be. Eris, roughly the same size as Pluto, more massive, has its own moon, sits in the scattered disk beyond Neptune. Haumea, ellipsoidal, spins so fast a day lasts under 4 hours, has confirmed rings. Makemake, bright, methane-coated, has a confirmed moon. Gongong, Quaoar, Sedna, Orcus, each of them spherical, each of them with moons, each of them on orbits the inner solar system has never had to reckon with. That is 9 bodies right there that meet every reasonable criterion for planethood except the one the IAU wrote specifically to exclude them. 9. And those are just the ones we have confirmed and characterized. The estimated population of dwarf planet-class bodies beyond Neptune sits somewhere between several hundred and over 1,000, depending on which survey you trust. Now think about what that means for the solar system you were taught. The solar system you were taught has 8 planets and some leftovers. The solar system that actually exists has 8 inner objects we can see clearly, and an outer architecture we are only beginning to count. Here is the scaling problem at the heart of the 2006 definition. The rule says a planet must clear its orbital neighborhood, but out there, the neighborhood is so vast, so sparse, so empty in absolute terms that no object, not Pluto, not Eris, not even something Earth-sized if you put one out there, could clear its neighborhood within the age of the solar system. The physics will not allow it. The orbital periods are too long. The gravitational interactions are too slow. The rule isn't a definition, it's a geography test that the geography failed. Every child memorizing "my very educated mother just served us nachos" is being handed a map that the cartographers themselves no longer believe in. The mnemonic survives because it is easier than the truth. The truth is messier. The truth is that the line between planet and not planet, drawn in Prague in 2006, was drawn through a population we had barely sampled, using a criterion that does not function in the region where most of that population lives. And the deeper you go into that population, the worse the problem gets. The next layer out, the scattered disk, the inner Oort cloud, is where objects like Sedna live. Sedna takes roughly 11,000 years to orbit the Sun. Civilizations rise and fall between its summers. And at that distance, the math stops adding up at all. The outer solar system is not a bigger version of the inner one. It is a categorically different regime. Colder, slower, emptier, older, and ruled by physics the inner planets never had to deal with. This is the part that most viewers, even ones who care about space, never quite internalize. The intuition we have for distances inside the inner solar system breaks down completely the moment you cross Neptune's orbit. It does not just stretch, it changes shape. Start with light. Light from the Sun takes 8 minutes to reach Earth. It takes over 5 hours to reach Pluto. To reach the inner edge of the Oort cloud, it takes over a year. Not minutes, not hours, years. A photon leaving the Sun today, traveling at the absolute speed limit of the universe, would still be in transit to the outer edge of our own solar system long after the people watching this video are gone. At Pluto's orbit, the Sun is a star. A bright one, the brightest in Pluto's sky by far, but a star. You could cover it with a pencil eraser held at arm's length. The noon brightness on Pluto is roughly the same as twilight on Earth a few minutes after sunset. That is the lighting condition under which an entire atmospheric cycle, an entire weather system, an entire geology is somehow still operating. Now scale that forward. A year on Sedna lasts roughly 11,000 of hours. Civilizations rise and fall between its summers. Sedna was at its closest approach to the Sun, its perihelion, somewhere around the time human beings were inventing agriculture. It has been moving slowly outward ever since, and it will not return to that closest point until somewhere around the year 13,000 of our calendar. We are watching it on a clock that does not fit inside human history. When astronomers say we discovered another object out there, the audience hears another rock. The reality is another world on a clock so slow it has been doing the same lap since before agriculture. Here is the comparison that should settle the scale problem. New Horizons took 9.5 years to reach Pluto, traveling faster than almost anything humans have ever launched. To reach the next interesting object after Pluto, Arrokoth, it took another 3.5 years. Arrokoth is still inside the Kuiper Belt's near edge. To reach the far edge would take a lifetime. To reach the Oort cloud would take a civilization. The scale alone should be enough to humble us, but scale is not the worst of it. The worst of it is what scale means for us, the bodies behind the telescope. The reason we are losing our ability to see Pluto clearly is not that Pluto is moving away. Pluto's orbit is slow, predictable, mapped out for centuries. The reason we are losing our ability to see Pluto clearly is that the instrument doing the looking is failing, and the humans who maintain that instrument can no longer reach it. Hubble orbits 547 kilometers above Earth. The last servicing mission was in 2009. No human has touched it in over 17 years. No human currently can. The Space Shuttle, the only vehicle ever designed to rendezvous with Hubble and carry the tools, the parts, and the trained crew to fix it, was retired in 2011. Nothing in the current American or international fleet is rated for that orbit and that mission profile. SpaceX has floated proposals. None have been funded. Inside Hubble, the gyroscopes are dying one by one. The telescope uses them to point and to hold steady. It launched with 6. It operates on 3. It has run on 1 before. Each gyroscope it loses narrows what it can point at and how steady it can hold the pointing. When the last one goes, Hubble does not gracefully retire. It tumbles. And the people who know how to operate it are aging with it. The astronomers who trained on Hubble in graduate school are now in their 50s and 60s. The engineers who built the instruments are retiring. The institutional memory of how to coax 35-year-old hardware through one more observing cycle lives in a shrinking pool of people, and there is no full replacement coming up behind them, because there is no equivalent instrument for them to train on. This is not a telescope quietly retiring. This is a piece of infrastructure aging out while the people who knew it best age with it. When Hubble goes dark, an entire way of seeing the outer solar system goes with it. Not because the science ended, because the eyes did. The press release version of this is gentle. Milestone, legacy, final portrait. The vocabulary is borrowed from retirement announcements, anodyne by design. The actual situation is harder. We are about to lose the only working instrument capable of giving us decades-long, high-resolution, visible light baselines on bodies like Pluto. And we have not built another one. We have not started building another one. We do not have a funded plan to start building another one within a timeline that bridges the gap. There is no equivalent replacement, not in orbit, not on the ground, not on the drawing board. Which raises a harder question. Why not? The honest answer is that JWST is not a Hubble replacement for this kind of work. JWST is an extraordinary instrument. It has reshaped what we know about the early universe and about exoplanet atmospheres. But it is infrared optimized. It was designed to look at faint, cold, distant objects in wavelengths Hubble cannot see. It can see Pluto. It cannot do the decades-long visible wavelength baseline studies that revealed Pluto's atmospheric cycle in the first place. Different instrument, different job, not a substitute. The proposed successor that would give us comparable capability is the Habitable Worlds Observatory. It is being designed. It is not being built. The earliest credible launch window is the 2040s, and that assumes the funding holds, the political environment stays favorable, and the engineering challenges of a 6-meter visible light space telescope get solved on schedule. None of those are guaranteed. By the time it might fly, Pluto will be deep into its winter, the atmosphere will have largely collapsed, and the window we are watching close right now, the one Hubble has been documenting for 30 years, will be gone. The next equivalent window will open roughly 200 years from now. Not in our lifetimes. Not in our children's lifetimes. Not in the lifetime of anyone alive on Earth today. And there is no follow-up mission to the Kuiper Belt funded after New Horizons. None. The spacecraft that gave us our only close-up of Pluto is now a single instrument drifting outward, its power source slowly decaying, and nothing is being built to replace it. No funded mission to Eris. No funded mission to Sedna. No funded mission to any of the other Kuiper Belt bodies we have catalogued. The entire region, the largest single piece of unexplored real estate in our solar system, is going to be observed for the next generation only from a distance, by instruments not designed for the job. When the press release says Hubble's last look at Pluto, what it means in budget terms is the last detailed look at Pluto until the people watching this video are in their 60s, or no longer here. Apollo ended in 1972. The next humans on the Moon are scheduled for 2027 at earliest. A 55-year gap, and that assumes the schedule holds. The gap forming behind Hubble for outer solar system monitoring is shaping up to be longer. If the science is this important and the gap is this large, the obvious question is why no one is alarmed in public. The answer is worse than budget. The reason this looks like a quiet, sentimental moment instead of a slow-motion loss of capability is that everyone involved has a structural incentive to phrase it gently. Not because anyone is lying, because nobody in the system has a reason to make it uncomfortable. Start with the language. NASA and ESA call it a milestone, a legacy, a final portrait. That vocabulary is borrowed from retirement announcements, not from infrastructure loss. It is anodyne by design. The agencies are not allowed to alarm Congress about a capability gap they do not have the budget to fix. So they phrase the gap as a transition, and the transition as a celebration, and the celebration as a tribute. The words are technically true, the frame is misleading. Then the IAU silence. A growing chorus of planetary scientists has formally proposed revisiting the 2006 definition. There are real, peer-reviewed papers, conference sessions, and working groups dedicated to the question. The IAU has not scheduled a vote. The longer it doesn't, the more the public assumes the question is settled. Silence becomes consensus by default. Then the funding architecture. Mars attracts congressional dollars because it is human-relevant, near-term, and politically legible. The Moon attracts dollars for the same reasons. The outer solar system attracts almost none. Scientists who work out there have learned to phrase loss as transition because alarm produces no budget. It produces fatigue, and then it produces dismissal. So they stop sounding the alarm. Not because the alarm is wrong, because nobody answers it. And then the audience psychology, which is the part most viewers never consider. Pluto is a planet again is a feel-good headline. It gets shared, it gets clicked, it restores something most people felt was unfairly taken from them in 2006. We are about to lose the ability to study a class of objects we barely understand. Is not a feel-good headline. It gets scrolled past. The algorithm rewards the first version. It punishes the second. I want to be careful here. I am not arguing that NASA is hiding anything. They are not. I am not arguing that the scientists are incompetent. They are some of the best people working in science today. I am not arguing that JWST is a failure. It is extraordinary at what it does. I am not arguing that the IAU acted in bad faith in 2006. They made a decision under pressure with incomplete information in a procedurally messy meeting. I am arguing that the comfortable framing is comfortable because nobody in the system has a reason to make it uncomfortable. Once you see the softening, you start asking what the softened story is actually about. And the answer is bigger than Pluto. The Pluto demotion, the Hubble countdown, the missing follow-up missions, the unwritten definition of planet, the unfunded successor telescope. These are not separate stories. They are a single pattern. Humanity is about to enter a long period where we know the outer solar system is more populated, more active, and more complex than we believed. And we will have fewer tools to study it than we did 20 years ago. This is not an astronomy problem. It is a civilizational attention problem. The same era that built JWST and landed on a comet is also the era that retired the shuttle, lost the ability to service Hubble, and stopped funding outer system follow-ups. We are simultaneously the most technologically capable generation in history, and the first one in 60 years to be narrowing our view of the solar system rather than widening it. That is not a contradiction the press has metabolized. It is a contradiction the field has been quietly carrying for over a decade. A historical comparison. After Galileo died in 1642, telescopic observation of the planets stagnated for nearly a generation. Not because the science had stopped being interesting, because the political and religious incentive structure shifted, and the people who had been doing the work either died or were no longer rewarded for doing it. We are not in 1642. The science is not being suppressed, but we are in a period where the will to look outward is being outcompeted, year after year, budget cycle after budget cycle, by everything else. And here is the part that turns the story from sentimental to serious. And I want to deliver it carefully, because the temptation in this niche is to overstate it. I am not going to overstate it. The Kuiper Belt and the Oort cloud are where long-period comets come from. They are also where the most dangerous long-period impactors come from. Not the near-Earth asteroids we already track, the ones we cannot predict, because they arrive from the outer dark on orbits we have never seen. And by the time we detect them, we have months, not decades, to respond. Losing capability out there is not only a sentimental loss, it is, in part, a planetary defense loss. Not the headline kind, the boring kind, the kind that shows up in long-range survey gaps that nobody notices until something arrives. I am not saying the sky is about to fall. I am saying the eyes we built to watch it are being allowed to close, and we have not built new ones, and the people in charge of saying so out loud have learned that nobody answers. Which brings us back to the image, and to what it really means that we made it at all. Pluto is not less of a planet. The definition was less of a definition. The outer solar system is not emptier than we thought. We are. Hubble's last look is not a goodbye to a world. It is a goodbye to a window. And the next equivalent window, if it gets funded, if it gets built, if it gets launched on the schedule its designers want, will not open for a generation. Go back to the image, the pale, dim frame, taken through aging optics, of a small, bright world 4 billion miles away. That photograph is not a portrait of Pluto. It is a self-portrait. It shows what we are still willing to see, and how much longer we will be able to see it. The instrument is in the picture as much as the subject. The instrument is the picture. And the title of this video, the headline that brought you here, "It's a Planet Again," is true in a deeper sense than the headline meant. Pluto is being re-recognized not because the science changed. The science was always on Pluto's side. Pluto is being re-recognized because the humility changed. A generation of planetary scientists who grew up with New Horizons, who watched a small, icy world break every assumption their models had built around it, is no longer willing to pretend the 2006 vote settled anything. The reconsideration is not nostalgia. It is professional honesty catching up with the data. There is narrow, earned hope here, and I want to give it to you, because the warning has landed, and you deserve it. The Habitable Worlds Observatory is not funded yet, but it is being designed by people who know exactly what we stand to lose. The IAU's definition is being challenged in print, in peer-reviewed journals, by scientists with nothing to gain from the fight except the right to be honest about the geography of their own solar system. The data Hubble has gathered over 35 years will outlive Hubble. The questions it raised will outlive all of us. Pluto is fine. Pluto has been fine for 4.5 billion years. It will be fine for billions more, drifting through its long, cold winter, doing whatever strange thermodynamics it is doing, with or without anyone watching. The question the image is really asking is not about Pluto. It is about us. It is asking whether we will still be the kind of civilization that bothers to look, or whether the next last image will be taken without anyone realizing it was the last one. Hubble looked at Pluto one last time. The harder question is whether anyone will look back.